In this video, I'm going to show you how to set up an array, set up a grid in your code, and show you how to build in rectangles using what I call the stop-start index approach. And then I'll show you a centering algorithm on how to center a rectangle in your grid. The very last thing we'll do is we'll generalize that, and we'll use the centering algorithm to build a triangle into the grid. So let's get started. Let's first just create a blank array to show you some simple things. So I'm going to create an array of 7 by 7 zeros. Now let's go ahead and put a 1 in the position that's maybe 2 cells over and 4 cells down. All right, whoops. Now we got to say equals 1. Okay, 2 cells over, 4 cells down. So if I come over 2 cells, so first cell, second cell, and 4 cell down, I don't see a 1 here. I see a 1 in the position that's 4 cells over and 2 cells down. It's backwards of what we're thinking. And that's because MATLAB is an acronym for Matrix Laboratory, is accessing this array not as an array, but as a matrix, where the convention is the first number is the row, or how far down in the array you are, and the second number is the column, or how far horizontally you are. So this is the second row and the fourth column, and that's where it has placed the 1. Now we're thinking in terms of arrays. So in fact, if we want to show this matrix more as an array of how we're thinking about it, we will do a transpose operation. And notice I'm using a period apostrophe. The apostrophe alone will take the transpose, but then also take the complex conjugate of everything in A. That's not a big deal to us now because zeros and ones are completely real, but later on, if we're working with complex numbers, that may mess things up for us. So the dot apostrophe does just the ordinary transpose, not the complex transpose. Now we're looking at this as an array. And so yes, okay, second cell over, fourth cell down, that's where our 1 is. And so when we're looking at arrays and not matrices, we're always going to do this transpose operation when we look at things. Okay. With that said, let's go back to A. Let's make this all zeros again, 7 by 7. Let's say I would like to fill in, let's look at this in array. Let's say I want to fill in this entire column here. So that's going to be the second column over, and I want to fill in the whole thing with 1s. Okay, now it's displaying it as a matrix, not an array. Let's display it as an array, and we filled in 1s. So that colon up here meant fill in the entire column and in the second position. Let's go ahead and make a, let's go over to the fourth column, and let's fill in from 3 to 5 with 2s. All right, now let's go ahead and look at A as an array. Okay, so fourth column over, and in position 3 to 5, we've injected all 2s or inserted all 2s into this array. So this is basically how we're going to do rectangles. We will have stop-start indices. So what I mean by that, we're going to start in the x direction, let's say at 2, go all the way to 6. In the y direction, maybe 3 to 5, and let's put 7s into this array. Let's go ahead and look at it. And here is a rectangle. And it's starting at the horizontal position 2 all the way over to horizontal position x, and the vertical position 3 all the way down to vertical position 5. So this is how we will do rectangles, by controlling these stop-start indices. Okay. Let's now make a script file. I like to have the first line be the name of my script file, so let me call this demonstrate rectangles. And I like to hit return a bunch of times because otherwise when my code gets crammed at the bottom, the editor window behaves weird. Something strange I like to do, I guess. Okay, so I'm going to copy, Save as. I will paste that name and say save. Okay. Always the first thing in my MATLAB codes, I will initialize MATLAB. I will close all open figure windows. I will clear the command window. And then the most important is clear memory. At this point, I will start a section of the code that I call the dashboard. Inside the dashboard is all of the hard-coded numbers. And so no work happens in the dashboard. I'm just defining width of my rectangles, size of the grid, that sort of thing. So let's come up with some grid parameters. So I will come up with the physical width and the physical height of the grid that I like to call big SX and big SY. And let's make the physical width, I don't know, 10. And we'll make the physical height also 10. Then the number of points. I'll make the number of points 100. And the number of points vertically, I won't hard code a 100 in here. What I'll do is I will calculate that from the above parameters. And what this will do is as I change the physical size of the grid, this will automatically adjust the number of points vertically to try to keep the cells in the grid as square as possible. And I think that's something good to do. Now let's define our rectangle parameters. Let's come up with a width in X. Well, we know that the physical width of the grid is 10, so we want to make it something smaller than that. Let's make it something like 7. And let's make the height of the rectangle something like 3. That way we can see that it is a rectangle. And we're going to center this. I guess we'll also experiment with not centering it, doing it left and right. Okay, so I think that's everything. And if we forget anything, we can always come back. So the next thing we'll do is calculate a grid. So this is all the other stuff that we've missed up here. And really what I need is my grid axes. And so I need an array that tells me the center positions of all the points horizontally across the grid. So I will go 0.5 to nx minus 0.5 times dx. Now inside these square brackets, I've created an array that goes 0.5, 1.5, 2.5, 3.5, all the way up. And then when I multiply by the cell size dx, which I haven't calculated yet, I'll get an array that tells me the center positions of each cell horizontally. So that reminds me, I didn't calculate a dx. What is the size of the cells in my grid? Well, in this case, it is the physical width of the overall grid divided by the number of points. That tells me how wide my grid cells are. Well, now I can copy and paste that. And I'll calculate dy, and that's the physical height of the grid divided by the number of cells tall. And then I'll come up with my axis vector that tells me the center positions of the cells vertically. I'm going to go ahead and run this. It won't appear to do anything, but I want to make sure that I'm not getting any errors. Notice as I'm typing this code, it's clean code from the very beginning, and I'm commenting, I'm doing spaces, I'm doing section headers right from the beginning. You don't want to write sloppy code, get that to work, and then clean it up because you never benefit from the clean code by doing it that way. Okay, I'll do this in 2 steps just to make my code read better. I'm going to make this first step read calculate grid resolution, and I'll have this one calculate axis vectors. Sorry for doing that to you, but I think that reads a little bit better. And in later codes, the next thing we'll do is we'll calculate mesh grids, but in this video, we're not using mesh grids. So I think that's it for our grid. The very next thing is to build rectangle on grid. And I always like to initialize my array to all zeros in the very beginning. So we'll make this all zeros, nx and y. And now, next step, we're going to do some stuff to build a rectangle, and we'll come back to that. And then the very last step, we want to display our array. So display array A. So first thing is show A. We'll use the image sc command in my day-to-day things. I will always use this command to display arrays because it shows it as digital data. Each pixel corresponds to a value in my array. I like this better than using pcolor for exploring digital data. And I will do the dot apostrophe because we're imaging an array and not a matrix. I always follow this with an axis equal tight unless I have a good reason not to, because it proportions my array, so my rectangle will look like how I want it to be proportioned. And I might even do this as a separate section of code saying set view. I will also want a color bar so I will know specifically what are the numerical values in this. And at this point, I won't bother to dress it up further. There's other MATLAB sessions where you can look at how to dress up your graphics. Okay, so we see a big array. It's some kind of greenish color, and it's all zeros. And of course, if I were making a final plot, I'd go in and adjust font sizes and other things, but I'm not doing that right now. We're just learning how to put a rectangle onto a grid. Okay, let's go ahead and actually do that. So we're doing this by stop-start indices. So we're going to, let's calculate our stop-start indices. At first, let's just do this manually. So we have on the horizontal direction a stop and start index. Let's fill in a rectangle from, let's say, 25. And the stop index will be 50. Then in the y direction, maybe we'll start at 10 and go all the way down to 90. So this is going to be a very tall rectangle. All right, now we actually incorporate the rectangle. And we will say A from nx1 all the way up to nx2, and from ny1 all the way down to ny2 equals 1. Now we should see a very tall rectangle. And it's almost looks centered vertically. I guess let me not center it just to show that we can offset things. Okay, so we have a rectangle inserted into our grid using this stop-start technique. Now let's center the rectangle that we have defined up in the dashboard. Okay, so we're going to erase these and do this an entirely different way. The very first thing I'm going to do is calculate the number of cells wide my rectangle is. So it's Wx over dx. And let me just comment out that because we don't have nx1, nx2, ny1, and ny2 defined yet. Let's go ahead and run this, make sure there's no errors, okay? And let's look at what nx is. We've calculated 70 cells. Now something can happen here. This does not necessarily have to come out to be exactly an integer. We got lucky, and we could come up here and we could change this. Let's say if our grid were 103 cells, and if we ran this, now if we look at nx, now we see it's 72.1. So our rectangle is 72.1 cells wide. Well, we can't do that. We can't fill in 1/10 of a cell. So really what we should do is round this. And I will use the round command rather than ceiling or floor, which rounds up or down. I'll use round to get the most accurate number of cells wide this rectangle is. So it's going to make it 72 cells wide. Okay, so now we need our stop-start indices. So the first thing I'll do, let's start with nx1. Let me just come over here. Let's first figure out where the center of our grid is. So that'll be the total number of cells divided by 2. This will tell me what array index is the center of the grid. From there, what I'd like to do is subtract half of the number of cells wide this rectangle is. That will tell me where the rectangle starts. So then what I'll do is I'll factor out the divide by 2 just to simplify things a bit. Again, we're calculating the array index where that rectangle has to start. So if I put a semicolon after this, let's go ahead and run that. I don't think that'll give us an error. Let's look at what nx1 is. A 15.5. Well, there is no array index that has a 0.5 in it, so we need to round this. And I'm going to round this a little bit differently. First, we'll put parentheses around this because that's the quantity we want to round. I am going to round down. So that means when this is rounded, this could start at 0. And MATLAB does not do its arrays starting at 0. It starts at 1 because it's thinking matrices. So I round it down because I'm going to add 1 to that. And now this is how I calculate the start index of the rectangle. I'll also add, most of the time when we're simulating things, we don't necessarily need to be real paranoid about the index where we start it, because the position of the rectangle is a lot of times not so important. What is important is that we get the rectangle in with the correct size. So we need to take even more care when we calculate the stop index. So we might think, oh, I could just copy and paste this code and maybe put a plus in here to get the right-hand side. And that could work, but we actually could be off by a cell by doing that. And in some simulations, being off by even a single cell can be really critical and throw our simulation off. So we're going to do this differently and actually much more simple. Where does this rectangle end? Well, we've calculated how many cells wide the rectangle is. So it's going to be the start index plus the number of cells wide this is. Now let's think about this for one moment. Let's say our rectangle is 2 cells wide, and we calculated the start index to be 10. So the stop index would then be 10 plus 2, or 12. So when we go ahead and we fill in numbers, it's going to fill in 10, 11, and 12. We would have filled in 3 cells. Well, we just said our rectangle's 2 cells wide. We filled in an extra cell, and we don't want to do that. So we need to subtract 1. And so that very accurately incorporates the width of our rectangle as close as we can get it to within a cell. I'll go ahead and copy and paste this and do the same exact thing, but I'll change all the x's to y's. So the width of our rectangle divided by the cell width gives the number of cells, I should have said width, the height of our rectangle divided by the height of the grid cell gives me the number of cells tall our rectangle is. And then we go ahead and calculate the stop and start indices following this nice centering algorithm. All right, and if I have not made any mistakes, we should get a nice centered rectangle. And if you recall from how we did our rectangle, it should be wider than it is tall. I believe it was 7 wide, 3 tall. Okay, and there is our rectangle, and it is perfectly centered in the grid. Okay, the last thing we will do is use the centering algorithm to make this a triangle. Let's go ahead and actually save this as a different code. So instead of rectangles, let's call this triangles. So I will go ahead and copy, save as, paste, and now we have an entirely new code. Now our triangles code is still doing a rectangle. So we need to change things, but this saves us from having to retype a whole lot. So triangle parameters. Let's make a triangle that comes to a peak at its top, has all 3 equal sides. So we just define the width of one side. And so let's call that, I don't know, 9. So this is going to be a real big triangle in the middle of our grid. All right, we calculate our grid the exact same way. We will initialize the arrays. It's all this stuff that is going to change. So let's leave this where, and we'll come back to that. The way we're going to incorporate triangle, we're going to set up a loop. And this loop is going to go from the top of the triangle to the bottom of the triangle in terms of array indices. And so we will calculate stop and start indices that take us from the top to the bottom of the triangle. So we won't need these x, but we'll leave that here and not mess with that because we're going to end up pasting that into this loop. So we need to go from the top to the bottom. Well, if we have a triangle that has a peak at the top, has all equal sides, what is the height of that? I'll save you the geometry. It is the width of the triangle times the square root of 3 divided by 2. That will be the height of the triangle. So if we want to calculate the number of cells tall, it's h divided by dy. And then we follow our centering algorithm, so we're centering that triangle vertically. Okay, now we're correctly going from the top to the bottom of the triangle. I'm going to go ahead and move this code inside the loop because we'll be using that and I don't want to retype it. Come on down. Okay. If I highlight it and say control right bracket, that automatically indents things for me. Okay. First step, I like to calculate a number that's going to go from 0 to 1 as we go from the top to the bottom of the triangle. If I was a smarter person, I could probably work directly with these numbers, but I just like to have a number that goes from 0 to 1, indicating from top to bottom. So let's do that. So to start at 0, we need an ny minus little ny1, because the first in the loop will be little ny equal to ny1. Now we'll have a 0. And then we will subtract ny2 minus ny1. That's the total number of cells over the loop. So the very last number, when little ny is equal to little ny2, we'll have ny2 minus ny1 divided by ny2 minus ny1. So it ends at 1, starts at 0. Now, if we're starting at the top of the triangle, I actually don't want this to be exactly 0. I want it to start at a very small number so we have some kind of width. So I'm actually going to add 1 to the top and the bottom. So it's going to start at something very close to 0, but not exactly 0. That's because our triangle isn't exactly 0 at the tip of it. Okay, so I'm just going to loosely say this is a parameter going from 0 to 1 from the top to the bottom of the triangle. Now I want to calculate the number of cells wide the triangle is as we're working from top to bottom. So it's going to start skinny and go fatter near the bottom. So let's think about that. What is the width of the triangle? It's going to be F times W. That's the physical width. We want to calculate number of cells. So we would simply divide that physical width by the cell width. Now, of course, this could come out to be some kind of fractional quantity, so we're going to round that. And we're not using ceiling or floor because we'd like to get a very accurate number, the most accurate number. And we don't need to change our centering algorithm. And let's go ahead and comment these. So we'll call this the calculate the 0 to 1 number. Calculate width of triangle at current position. Calculate stop-start indices. And then last, we actually have to incorporate the numbers in the triangle. So incorporate ones into A. So we're going to say A from nx1 to nx2 at position ny equals 1. Now, if I have not made any mistakes, we should see a triangle. I'm going to come up here and indent my equals because I'm strange. I like my equals aligned. Okay, let's see if this works. Hey, there we go. There's our triangle. And also notice one last thing. We are controlling everything through the dashboard. I can come up and say, oh, I want a different width triangle. The sign you're doing something wrong is if I were to change that width, if I would also have to come down and change other things, I know that I'm writing my code incorrectly. I can control everything through the dashboard. That's how we know we've done things correctly. Well, I hope you'll find this video helpful. You can do a lot with these techniques and center things other than just rectangles.